Hi guys, this is John TV, no, John Channel, no, John Times, and I am John. Today, I'm introducing a formula of bow and arrow. So, that's really, alright. So this is the diagram of bow, right? And then, looks like half a moon, but, so, you have a bow right now, and you pull this thing at this part, which hold this board in the curved shape, right? So you pull them like that, and then what you're doing now is when you pull it, you are storing the potential energy, and when you release it, the momental energy, momental energy is the potential energy changed into momental energy, like that. So physically, let's make this in the let's describe the diagram as physics. Wait a second. Okay. So, I define that this lens, okay, that's pretty awful. Maybe that's better, right? By the way, I'm the boy, yeah. Be sure with that. And then I define that this length, the meter, much as you pull, I define as R meter. And then the half length of this thing is H meter. So, and then this is the force of sting force, when you pull this thing from this way and other way, what happened is that you are pulling sting like that, right? And then sting this way, and you pull sting like that. And they are all same force because that's the rule. And then, so while you are pulling this thing, your the force of the sting force has been bigger, larger. Yeah, because that you're pulling for stronger, right? I define that as SF. And then the force of opposite. The Newton's law for third Newton law, called, I forget that. What is it called? Okay, never mind. And there's a rule that Newton discovered, which is when you push or pull something, the force you pull or push. Also, when you push or pull for something, the thing which is pulled or pushed also pushing or pulling with literally same force. So, according to that law, the force has been like that, and I define as Fs. Sorry, and Fs equals Sf plus S and S, they're equal, and also them, and also them, so also, and then so Fs, the force of Fs is is showing the way of maybe, I don't know, 60 degrees, right? Like that. 60 degrees compared to this. If this is the 0 degrees, this is 60 degrees, right? However, what we are finding is that force of this way, right? And this is important, and because that describes and that represent the force, right? And it is, I define as F, force, and this is Fs, and this is S, and this is F, right? So we can say that this Fs is divided into F and S. You're coming? I mean, you're... My English is just awful. So the Fs, the force called Fs, is divided into F and S, right? How many times did I say yeah? No, right. Interesting. This is the, and then I define that this degrees, the degrees of this thing, degrees of difference between, the degrees which describe that difference between, if I define that this degree as 0, this is theta degree, and that is called theta. Maybe the spelling is wrong, but I don't care. And this is theta. So, according to math of shape, this degree is also theta, right? And then these fact shows that the r divided by h equals tan theta. And in addition, this knowledge is the high school math. So maybe you can search with triangle relationship in high school. I don't know, but yeah. And also, this theta can describe as f divided by s equals tan theta, because these degrees are same, right? And I'm dividing the length divided by this length and length divided by this length. So there I proved that r divided by h equals f divided by s. And then making in the formula for this f, I can describe as SR equal SR divided by H equals to F. And that's the force. And this equation describe that this force, I mean the force of this way, not that way, the way that the ball flew, and the force equals to S times R. So this thing force times the length of how much you pull times dividing with H, which is half length of a whole string. And you should be careful that this is not completed formula, because you have to time by 2, because this formula is representing just for this side of force and not for that side. So sorry, I forgot doing this. This is 1, this is 2, and this is 3. So 3 times by 2 equals, I define as F something. So F something equals 2RS divided by H, because I times by 2, right? And then this equation describes literally the force when we pull the arrow of the half of string is 8 centimeter for 8 meter for 6 meter pulling, 6 meter of pulling the string, which the string force when is Fs, and times by 2 equals the force of arrow force, which is force stores, right? However, this equation is not still completed, because if I say, like, how much is 10 Newton? 10 Newton is 10 Newton. It's nothing more and less, right? But that's kind of complicated, right? How much is 10 Newton? We can't describe that. And we also don't know how much is 10 Newton, right? With our body. So, according the law of second Newton's law, which is called F, force divided by mass equals to acceleration. And according to this equation, I can show that dividing by m a something equals 2rs divided by mh, mass times half of stink, meter, the length, half of stink, and that equation describes how fast, like how fast arrow go through from zero velocity. Like how much is changing from zero velocity to movement. And that's what this A describes. And then the formula S means the S describes the diameter じゃなくて distance. Come on. S describes what did I say? Diameter じゃなくてdistance. S describes the distance, and S equals half of g, gravity acceleration, which I mentioned before in last video, times, and this is, by the way, this is 9.8. This describes that. G describes that. The accelerate of 9.8 meter per 1 second. And the G means acceleration which describes the acceleration of the dropping thing in the earth is 9.8 meter per second, and times by time is time passed. However, this is just for equation when we drop the something, so we have to change into normal, regular acceleration, because I'm not talking about dropping thing in the earth, not considering the air resistance, right? And by the way, I'm not considering the air resistance for this equation, because that's too complexable. So S equals, I substitute this into A, right? And then S equals to 1 times 2RS divided MH times T squared, right? Oh, S equals, erase that, and then that's state, and that's going bound. Oh, sorry. Maybe, yeah, they're seeing. So I have to make a difference. Okay. Making an H. That's much better. So the H describes the distance which the boat flew, and then the distance can describe within the formula of R times S times time squared dividing with M massive times H. Okay? Did you get that? However, who knows that? Who knows second? Who knows how long takes to go or dropping, right? Like, we have to there's no way to describe the time, right? Or we just have to using time watch to measure, and that's like unreasonable way. So for solution of this problem, I use the formula which I mentioned before, S equals gt squared. So as I mentioned before, this formula describes the distance which falls the starting point to bottom, and that's what this equation describes. And then so this is the formula which came up with from Galileo, and this another thing, another stuff is also idea which came out from Galileo. let me throw the ball from here. The ball is dropping like that, right? It doesn't drop like literally with 90 degrees, and that's not correct. So the ball is dropping with decreasing, like within curved shape. Writing in a curved shape, curved line. That's not the line actually, but yeah, curved. And think this is arrow, then it's, yeah. I use the example of ball because that's much more simpler, but think that is arrow for, yeah. And the height, what is this? I hate the height of the boy throwing the ball is, is what is this? This is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. This is L. This length, this length is L meter. Okay? And there is a Lao called how we say that in English? Independence of movement. The movement of independence of movement. I don't know. Maybe either is fine. So the Lao called independence of movement, which shows that even the velocity of whether the velocity of the ball, no matter what, the time, the second to jump of this distance is determined no matter what, how fast you throw, velocity of the ball. And so that the fastness of this speed and this speed has any of a relationship, and that is the independence of the movement of two of these. That's what I'm describing. So when the ball dropped for L meter, I use this equation formula that I just change S into L so that we don't mix. It's not chaos with this as the sting force. And what we are solving now is time, right? The time, how much time passed for that length, dropping of that length, right? So making in t's the time, making the equation of time, t equals root 2 times L divided G. And this equation represents the time passed for this height to ground. And what we're solving now is t, this t, right? So I substitute this number in that t. So what we came up with is h equal massive times length of half length of arrow and half length of the string, and r the length you pull from the 0 degrees times string force times it has been squared, so the root is taken off and then divided by G. And making it simpler and simplifying that, R S M H times G. And this equation describes the RS and this equation describes a distance of arrow flew equals to 2 times, for example, for so 2 times that distance, r meter, times the string force, S, times the distance of L meter of location of the ball to the ground, L meter, divided by massive of arrow times gravity acceleration, which is 9.8 meter per second, times h meter, between the h meter half of the string. So h equals 2RSL divided mgh, and that is formula which describes a distance of arrow flew. that's all. Thank you for listening. Thank you. JK. I really have to improve my English, because my explanation was awful. Okay. Bye. And by the way, tomorrow I'm also posting the new video. That's all. And that's final.